Hi everyone. Well, in our last lessons, we were learning how to find the power of products or the products of powers. And when we were doing that, we were looking at solving based on just looking at the exponents. So either multiplying the two exponents together or adding them when they have the same base. Well, today we're going to be doing something very similar, except today when we're looking at our problems, we're looking at division or finding the quotient. So today we're looking at how do we divide powers when they have the same base. So finding the quotient. The property or the rule, the math rule we're using today is called the quotient of powers property. But first, before we talk about what the words are with that property, we're just going to start looking at some examples. So we will have some problems, and they look like this. So we have 2 to the 6th divided by 2 to the 4th. Well, in the quotient of powers property, it says that we can solve this because they have the same base by looking at just the powers. So division, we're going to be dividing, and the opposite of division is multiplication. So in multiplication, which we did in our last lesson, we were adding. Today we're going to be looking at subtraction because subtraction and division go together. So we're going to be looking at subtraction, and the way that we solve these problems when it's a division and they're the same base is you just take 2 to the 6th minus 2 to the 4th, or minus the power of 4. Oh, I just smeared that, sorry. So now our problem, or our powers, are 2 to the 2nd power. So we can think about this fraction here as meaning divided by. That fraction line means divided by. And you can also think of this problem as 2 to the 6th. So we have 2 times 2. So our repeated factors, if we were to repeat all of our factors and put them over, you can look at this problem now and you can see how they cancel out. So 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. And 2 divided by 2 is 1. We have nothing left over here, so we have 2 to the 2nd power. Let's look at another example. So in our next example, we are looking at a negative number, so negative 7 to the power of 9, and we have that divided by negative 7 to the power of 3. So the quotient of powers property says that because they have the same base, all we have to do is just subtract their exponents. So we're going to take 7, our base, slide our base over, which is negative 7, and we're just going to be subtracting those two things. So 9 minus 3. 9 is on the top, it comes first. 3 is on the bottom, so it comes second. 9 minus 3 gives us 6, so we have negative 7 to the power of 6. Again, we can look at this as saying negative 7 times negative 7 times negative 7. 1, 2, 3, 4, 5, 6, 7, 8, and 9 over negative 7 to the 3rd. So we need 3 of that one as our repeated factors. And then they cancel each other out. Negative 7 divided by negative 7 is 1, 1, and 1. So we have 1, 2, 3, 4, 5, and 6 left over. those make up our exponent. Okay, so as we're looking at these different problems, you can see that our understanding around fractions, so equivalent fractions or dividing numbers, knowing that this line right here means to divide. So this line also means division. Goodness, of course I run out of my orange pen. Means division. Okay, so that's important for us to remember. Okay, let's look at another example because this also applies when we have algebra or variables. So let's look at this example. This example here says h to the 7th divided by h to the 6th. So again, all you're doing is looking at your base. So slide over that base number, which is h, and then we're subtracting the top exponent minus the bottom exponent. And 7 minus 6 is h to the 1. This is redundant. We don't need to write h to the 1 because h to the 1 just equals h. So all of these are equivalent, but our final answer is h. So if we were to write this out and see how it actually works in repeated factors, and we put that over the second h, that is an h, 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 and h, and h. Okay, and then these cancel each other out. You get one h left over, which is our answer. Okay, let's do one more example with the repeated, with the factors, so simplifying. And this time I want to do it as a fraction so that you have that example in your notes. Okay, so our last example before we talk about the definition is that we have 1/4 to the 5th power over 1/4 to the 2nd power. Now this looks weird, right? Because you don't typically have a fraction over a fraction unless it's a ratio. Okay, so unless it's a ratio. Otherwise, these would be things like, sometimes you might have a decimal too. A decimal for 1/4 would be 0.25 or 25 hundredths. Okay, so when we're looking at this, we're just looking at this divided by this. So our base, we want to know what the base is. Our base that we're going to slide over is 1/4, the whole thing, not just the top and not just the bottom. We're going to look at our exponents just the same, 5 minus 2. And then we're going to see that that equals 3. So our new exponent is 3. Our base is 1/4 to the 3rd power. All right, I'm going to go ahead and turn the page right now so that I can write out the definition for you. Hit pause if you need to finish writing this example. All right, so let's talk about our rule or our property that we've been working with. So the rule that we're looking at today is called the quotient of powers property. Quotient, we know quotient means to divide. Quotient of powers, powers we know are numbers raised to an exponent. So quotient of powers property. And that's like our rule, our math rule. And it says that to divide powers with the same base, you just subtract their exponents. So to divide powers with the same base, you just subtract the exponents. And again, I will do like we've done in the past and point arrows to the different parts of this. Okay, so our quotient of powers property says that you have powers with the same base. You just subtract exponents. So here's your example. Here's our powers. 4 to the 5th over 4 to the 2. So here's the ones with the same base. When you have something like this, all you do is you take these exponents, 5 and 2, and that gives you 3, and then you just rewrite it. So our new one is 4, that's our base, is 4 to the power of 3. All right, it is your turn now for your try-its. So as soon as you're done writing that, go ahead and get ready for those try-its. You're going to want to hit pause too so you can solve these problems. So try-it number 1. Try-it number 1 is 9 to the 7th divided by 9 to the 4th. So find the quotient of that one. Try-it number 2. Try-it number 2 says, oh, here's a good one with some decimals. 4 and 2/10 over, or divided by 4 and 2/10 to the 5th power. So 4 and 2/10 to the 6th, 4 and 2/10 to the 5th. And then our last problem, you guessed it, is a negative. So you have negative 8 to the 8th over negative 8 to the 4th. All right, go ahead and hit pause right now so you can solve these on your own without hearing me. When you are ready, come on back and check your level of understanding. All right, so 9 to the 7th, I have a base of 9. I subtract 7 and 4, and my final answer is 9 to the 3rd power. Okay, our next one, I have 4 and 2/10. That is my base. I'm going to subtract 6 minus 5, and I get 4 and 2/10 to the 1, or just 4 and 2/10. Again, I don't need this 1 because it's already one number. All right, and our very last problem we have is negative 8 minus 8 and 4. Those are our exponents. Again, keep this in parentheses because we want the whole thing, not just the 8. We want a negative 8, and 8 minus 4 is 4, so I have negative 8 to the 4th power. That is my final answer. All right, how did you do, or how are you feeling about this lesson? Check your answers. How did you do out of 3? And then go ahead and answer your essential question. How do we divide powers with the same base? And then put your level of understanding out to the side. How are you feeling about your understanding for dividing or finding the quotient of powers when they have the same base? All right, it is your turn now to go and do your practice work. If you have any questions, please come on back to the Google Meet and ask for help, or you can go on to Big Ideas and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great